Hello all. Today we are going to discuss about replication in Kafka. So let's consider we are working with an ordering application. So there is a producer which is ordering API. This API will receive orders from the front end and it will create the orders in its database and then it will insert this message into Kafka. So all the consumers which needs this order details will subscribe to this Kafka topic and then they will consume the messages. So this is the producer and these are the consumers. So for example, ordering API is the producer and notification API will be the consumer, one of the consumers. So which needs the ordering details. So for every order, it will send email and SMS to customer. And there can be one more payment API, which is a consumer. For every order, it will take the payment and make the payment. So now there should be a topic to insert these messages. So there is a topic called order place topic. In this topic, the order API will insert messages in Kafka. So in Kafka, you know that it's not installed in one server. It is generally installed in multiple servers. They call these servers as brokers in Kafka. So now let's say there are 4 brokers in Kafka. So that is why we call Kafka as a cluster, not just a single node or machine. So there are 4 brokers in this Kafka cluster. Now the order creation topic, order creation created topic is present in Kafka. As we know that if there is lot of load, we can distribute the load in Kafka. That means, so the order creation topic, if it is very big, so let's say there are 3 million messages or 3 million orders, we can spread the 3 million across probably 3 different brokers. So this is one, probably we can store one here and one here. The same topic we can store in multiple places. So each one is called a partition. This is partition 1, this is partition 2 and partition 3, which means 1 million messages will be stored here and 1 million will be stored here and 1 million will be stored here for the same topic. But the problem here is, for example, due to any disk failure or hardware failure, if some broker is down, that means all the 1 million messages are lost. So which is not correct. We cannot lose even a single message. So what is the best option? Let's take backups for this in other machines. For example, if order creation topic partition 1 is present in broker 1, you can take one backup of that into broker 2. So order creation topic partition 1, and maybe you can take one here, order creation topic partition 1, order creation topic partition 1. So if you see, for the same partition we have taken multiple backups. So there are 4 places where we store the same data. So even if broker 1 is down, we have these 1 million messages in other 3 machines. So this is good, right? Now the thing is, how the producers knows where to insert the messages. Should we insert in broker 1 for partition 1 or broker 2, broker 3 or broker 4? Generally what we do is we allow producer only to insert into one broker. So the others will have read that broker and it will take the latest messages and update in its system. So all the writes will be taken only by one machine. So producer will insert those messages into one machine. So this is the, let's consider this is the main machine for partition 1. So in Kafka we call this as the leader. So and these will be called as the follower, follower 1, follower 2 and follower 3. So the B1 is the leader broker for partition 1. B2 is the follower broker for partition 1. B3 is the follower broker for partition 1. B4 is the follower broker for partition 1. So now all the writes will be happening into the leader for any partition. So let's say producer has trying to insert a message into partition 1. it will insert into leader. All the followers continuously poll or read the messages from the leader, and they will update in their systems as well. So this will happen on real time. So that way all the four systems will be always in sync. So this is good enough, right? So who will take, let's say there is a failure case where B1 is down. Previously, this is the B1 is the leader for partition 1. So now there is no leader. So from where these three followers will read the messages, and from where now to where the producer has to insert, and from where consumer has to read the messages, as there is no leader. So there is a program in Kafka called kraft. Previously, this was handled by a program called Zookeeper, but nowadays we are using kraft. What this program does is, this program continuously monitors and maintains the metadata about which partition, in for which partition, who is the leader and who are the followers. So if any leader is down, it is the kraft's responsibility to elect another leader from these three followers. So for example, as leader is down, it will consider, it will have its own election algorithm, leader election algorithm. It will apply that algorithm. It will randomly take one follower and it will make that as a leader. For example, it made follower 1 as leader. So now for partition 1, broker 2 is the leader broker. Now all the other followers will read broker 2 to read all the messages from partition 1, and they will make their systems in sync with the broker 2 partition 1. Even the producers also, while inserting any messages, now it will insert into broker 2 for partition 1. Even the consumers also will read from broker 2 for partition 1. So this is how it works. So kraft will do an election, and then it will assign one of the followers as the leader, and all the brokers will read that metadata from the kraft, and all the brokers will be updated with the who is the leader and who are the followers. So this is how it works. Now if you come from the producer point of view, now instead of write, now he wait for all the brokers to be updated with his message, so that he can be sure that his message has been written successfully. So for example, so producer want to insert a message M1. So the M1 belongs to order creation topic and partition 1. So he knows that the, let's say B1 was up at that time. So B1 is the leader, and B2, B3 and B4, these are followers, follower 1, follower 2 and follower 3. Now his use case is, let's say he once he inserts a message, it should be updated in all the machines, then only he should get the response. Why? Because he want highly consistent system, so he should never lose at least one message. Probably he is using some banking app, so the Kafka cluster is storing the messages related to banking, so he should not lose any one transaction. So in that case, it is good that the producer can wait for all the servers to be updated with this message, then only it will send a response. So there is an option called acknowledgement. So in the producer app, he can set this acknowledgement option. There are three possible options that he can set. One is 0, the other is 1, and the third one is all. So in the example that we are talking, if he wants his data to be updated in all the servers before getting a response, he can set the acknowledgement as all. All means leader plus followers. So for example, if the leader takes, to write in leader it takes 1 millisecond, in for every follower it will take one more millisecond. So in final it will take 4 milliseconds to write into all servers. So after 4 milliseconds he'll get a response saying that your message has been successfully committed into Kafka. So I'll consider a case where, now instead of a banking example, let me take YouTube likes or Amazon uh, the ratings example. So generally people give some ratings to every product, right? Rating, they'll put a message saying that what is their feedback, reviews and everything, right? So these reviews will be written to Kafka by the Amazon Review API. So the analytics API will go through this all the reviews and it will make some decisions out of this so that they can forecast which product is being used more, what is getting more likes, more review, and which are getting low review, so that they can from then on they can plan their business accordingly. So that means the all the reviews will be written into the Kafka. So here the producer, he want to insert the review as quickly as possible into the Kafka. So his idea is, even though if few reviews are lost in the Kafka due to server failures in Kafka, it is okay for him because he is not storing all the reviews it's not any personal data or banking data. It is just for his analytics. So if few messages are lost also out of 1 crore messages or some millions of messages, it doesn't make any difference. So he is okay to lose messages. So consistency is not important. So in that case, he can choose acknowledgement setting as 0, which means as soon as Kafka reads the message, it will send the response back. So let's say it takes 2.25 milliseconds for Kafka to take this message, but it hasn't updated even in later also. It hasn't updated in any servers. Straight away it send the response. So in this case, let's say all the servers fail or the leader fails. So you lost that message, right? Or the broker which is processing these messages, it hasn't updated into the database, but due to power failure, if the RAM was down, so again if it is up, you lost that message, right? But the producer is okay with that in this scenario. So in that case, you can go with the acknowledgement as setting as 0. But what is the benefit of this? The latency. So the latency is very high here. So it is processing the request very quickly. 0.25 millisecond is very fast. So if you want fast when compared to consistency, you can go with acknowledgement as 0. And let's say if you have a third use case, which you need, where you need average consistency and average latency, then what you can do, you can consider acknowledgement setting as 1. Here what it means is, it will update in only one server, like leader. Once right, once the message is successfully written to the leader broker, then it will send the response back. For example, if it takes 1 millisecond to write into the leader, after 1 millisecond you will get the response. But the only issue here is, even the RAM is down, it's okay. uh, but if the complete machine is down and there is no, it was not committed anywhere, then that means your message is gone. But so it is, you can say it as a medium consistent and medium latency. So I hope you understood this clearly now, what is acknowledgement and when to use which acknowledgement setting. So this is about acknowledgement. So, and I'll take a scenario where let's say there are 4 replicas. One is the leader and 3 are followers. This one is taking 1 millisecond, 1 millisecond and 1 millisecond to update, insert the message and commit it. But for example, this is always being very slow because of some network issues. This broker is very slow and it is taking every time 3 to 4 seconds. So if the acknowledgement setting is 0, then it is fine because we are not updating any server, we are sending the response to producer. Even if it is 1, that is also okay because you are updating only in leader, so leader is fine, so it is sending the response. But if the acknowledgement is all, that means it has to wait to update in all the replicas. So even though these are faster in 1 millisecond, this is making everything slow. In total, you are waiting for more than 4 seconds in order to send the response. So there is an issue here, right? So because of one slow machine, you are, for every request, it is taking more time to respond to the producer. So producer has to wait for a long time. So to avoid this issue, what Kafka's Kraft software will do is it will continuously check which all brokers are very slow, and it will remove them from its list of the replicas which are important or always faster or in sync. So for example, these three replicas are very fast. So whenever a message is written to the leader, it is quickly syncing them into their replicas. So then it will call this as in sync replicas. So leader, follower 1 and follower 2 of order placed topic and partition 1 are very quick and in sync replicas. So when the acknowledgement level is all, it won't check for F3. It will write in only these three in sync replicas. Once it is written, it will update to the producer saying that the message has been committed successfully. So this is better when compared to the above approach, right? So here we are waiting for the slow server also. So you can think of a scenario where, uh, for example, all the three are slow, only one is faster, and the in sync replica metadata says that only L is faster for this partition. So then it will update only in this partition, in this server, in this broker, and it will send response to the producer. But the problem with the producer is he would have chosen one if he only needs it to be updated in later, right? When he says all, which means he want it to be updated in multiple machines, not just one. So in this case, the producer can force Kafka to say that I want this my message to be updated in at least two partitions or three partitions. He can mention that. So there is a setting to mention in sync replicas, minimum in sync replicas count. If you mention as two, which means at least it should be updated in two in sync replicas. So that means Kafka has to maintain at least two replicas, in sync replicas. It should be updated in at least two. Then it has to update in these two. Then only it should send the acknowledgement back to the producer if the acknowledgement setting is all and the minimum in sync replica is 2. So this is all about replicas. I hope you understood everything, right? So we discussed about replication, and we discussed about when the master or the leader is dead, how the election happens, and the kraft how it find out I mean elects the new leader, and so that all the other followers, producer, consumer will then read messages from that particular new leader. And what are the acknowledgement levels, what is 0, 1 and all, when to use which one, and what is in sync replicas, what is min in sync replicas. So I hope all your doubts related to replication has been cleared now with respect to Kafka. So we'll see you in the next video. Thank you very much.